Welcome back. This is the second half of 5.1 in determining the shape, turning points, and behavior of polynomials. The definitions here are great notes for your Cornell notes, and especially the turning points and behavior descriptions. Let's take a look at our first graph right here. Just from the polynomial, we can determine the maximum number of turning points and the end behavior of the graph. For example, this has a positive a value and an even index. So that means our behavior is going to be up, up. When it's even, or excuse me, when it's positive and even, it's going to be up and up. The turning points, take a look. We have turning points here, here, and here. We've got a change in direction from here to here. That's going to be your negative 1.07 and negative 1.04. The second turning point is right here when we're going from up to down. That's negative 0.27 and 0.17. And then here we had a change of direction from down to up at this coordinate 0.22 and negative 0.15. Here's how you would describe the increasing and decreasing. The function is decreasing when it is less than negative 1.07. It increases. Oh, sorry, let's not decreasing here. They have it all spelled out, and that's nice. It's decreasing when x is less than negative 1.07 and x is between negative 0.27 and positive 0.22. So it's decreasing here, therefore it must be increasing here and increasing here. So it's going to be increasing from negative 1.07 to negative 0.27 and up here. So between here and here, it's going to be increasing from these two coordinates, and it also increases when x is greater than 0.22. This is a pretty difficult graph. I'm glad they started off with this tough one first, because some of them are, I think, a little bit more easy to understand right off. Let's take a look at our next one here. We have a negative a and an even. When it's negative and even, it's down, down. Your turning point is right here. Change in direction. We have to go from left to right when we're reading this. Just like a sentence. We're going up, then down. So we're going to be decreasing after this point. So we have one turning point right here, and the function is increasing when x is less than 1. So it's going to be increasing when x is less than 1, and when x is greater than 1, it's going to be decreasing, as they have here. Let's take a look at a couple others. Here you have a positive odd, and when it's positive odd, it's going to be down, up. There are no turning points here. It seems very interesting. We actually have no change of direction. You're saying, well, Mr. Bova, wait a minute, it's flat right here. Well, guess what? It is flat. That does not mean it's a change in direction. This is going increasing, flattening out, and then increasing again. You might want to think of this as an airplane. If an airplane is going up, it flattens out for a little while, then maybe goes up in altitude. So there were no turning points, they just went up and up, which means no turning points. And it says here the function is increasing for all x. So as for all the x's, the y values will be increasing. Next one, we have in negative odd. When it's negative odd, you just switch these around to up and down, up and down. The turning points are going to be right here and right here. So at negative 0.82 and negative 1.09 is a turning point, and positive 0.82 and 0.09. Well, it's also another turning point. The function is decreasing when x is less than negative 0.82. So again, we look at these decreases here and here, and then just one increase. So the decrease is going to be here when x is less than negative 0.82. It's going to be decreasing still when x is greater than 0.82. And here is just the part where it is increasing from negative 0.82 to 0.82. We have to describe those and their coordinates. I know that's a lot to think about. Thank goodness we have a little chart that we should probably put down in our Cornell notes. This again describes the end behavior. Positive, even, up, up. Positive, odd, down and up. Negative, even, down, down. Negative, odd, up, down. You might want to also try and write this as a positive, negative, even, and odd, and then do the sometimes people will do the arrows and describe the end behavior that way. Make a little chart like that. It's whatever suits your learning needs best. So let's take a look at describing some end behavior of these functions. Here, I went ahead and blew up the little chart here and make that a little bit bigger. This one has a positive, odd. This one has a positive, even. This one has a negative, even. And this one has a negative, odd. So let's take a look. Positive, odd. Positive, odd. So it's going to be down, up. We've got positive, even, up, up. And negative, even, down, down. And negative, odd, up, down. Really a handy chart to memorize. So what I'd like you to do is to go ahead and take a quick practice on these three and determining what the end behavior is. So hopefully you did that practice. I'm going to go ahead and show you the answers here. These are the end behaviors of those polynomials. Let's move on to the section of what I refer to as NAGs, nags, and nags. Numbers, algebraic, graph, summary. For these end behavior questions, we're going to have to go ahead and graph these, find the numbers. Here's the algebraic expression, but we'll probably have to put that in standard form, discuss the end behavior, the maximum number of turning points, and the intervals, decreasing or increasing. So do me a favor, copy down this structure, and you're going to have to create yourself a little graph here to graph along. I'll give you a couple seconds to do that if you would like to pause the video. So let's first get this in standard form. And then plug in our values 2, 1, 0, our back 5. We're going to have negative 2 cubed plus 3 times 2. We're going to have negative 1 plus 1 cubed plus 3 times 1. Negative 0 cubed plus 3 times 0. Same thing here. So negative 1 plus 3 times negative 1. Wow. And we're going to have negative 2 cubed plus 3 times negative 2. So let's take a look at these. This is 2 cubed, which is 8. That's going to be negative 8. Negative 8 plus 6 is going to equal negative 2. This is going to be 1 cubed, which is 1. So it's going to take the opposite, negative 1 plus 3. It's going to equal 2. 0 and 0, that spits out an easy 0 for us. Negative 1 cubed, negative 1 times negative 1 times negative 1. Remember, it's going to be a negative 1 times a negative. It's going to be a positive 1 minus 3. And here we're going to have negative 2 cubed, negative 2 times negative 2 times negative 2. It's going to be negative 8. Take the opposite of that. It's going to be positive 8. And then 3 times negative 2 is negative 6. And we're going to have a 2 here. So let's plug in all these values and then graph them. 2, negative 2. 1, 2. 0, 0. Negative 1, negative 2. And then negative 2, 2. So you can kind of see from this graph that we're going to have a kind of a U-shaped, or not a U-shaped, kind of a backwards N graph. Draw a smooth graph through all these points. Now, remember, we have to take a look at the M behavior, and this was, this was negative odd, so that means it's going to be up, down. Let's go back and check our notes on that, make sure that's right. We had a negative odd, so we go to negative odd, up, down, good. And so it's going to be up and then down. Now let's go ahead and find our increasing and decreasing intervals here. It's decreasing here and here, so it's going to be decreasing when x is less than this number right here, which is negative 1, and when x is greater than 1. It's going to be increasing here, so it's going to be increasing when x is between these 2 points of negative 1 and 1. So when x is less than 1 and x is greater than negative 1, right here, it's going to be increasing. Now, we've got other examples on this, but this is basically your NAG structure, and we'll talk a little bit more about this tomorrow, and then we'll get you started on the homework. Hopefully you have a good weekend. Till next time.